Good morning, everyone, and welcome to a Savvius webinar. Today's topic is ensuring high-quality unified communications. With that, I'm going to turn it over to Jay. Go ahead, take it away.
Thanks, Matt, and good morning, everybody, and thank you for joining us here at Savvius. This is a bit of a follow-on from a unified communications webinar that we did a few months ago where people were asking a little bit more about best practices and a little bit more about where to see information and do a little bit of troubleshooting inside of the tools that Savvius provides. So that's really the slant we wanted to take a little bit more this morning. I'm pretty sure that many of the people that are in attendance, if not most, had probably already either was in attendance at the webinar, the last one, or have looked at the video in between. So I am going to duplicate just a little bit of the information up front just to get us all kind of grounded, but I will try my best not to recover the same ground that we covered the time before. So again, the topic is about ensuring high quality unified communications, and get things to click. There we go. So the agenda, I just want to do, and this is one thing we did talk about last time, do just a quick review, far less slides than last time, about the quality metrics that are involved in monitoring and managing and troubleshooting unified communications. Then look at some best practices from an implementation standpoint. Certainly we have experience here. We do like contracting to implement, and this implementation is something you're going to verify with packet analysis, but I think it's important to know what some of those best practices are. And then a slide on best practices in troubleshooting, which of course is where we very much come into play. And then we'll look at a few troubleshooting kind of issues from within OmniPeak to see where we see the appropriate information for helping us to begin to troubleshoot unified communications problems. So on the quality metrics, real quickly. But before even getting to the quality metrics, I just wanted to, and again, I covered the last time, but I just want to cover this quickly again. What is it about unified communications, and what specifically is about unified communications on the network? So unified communications, of course, is as the definition says, a unification of all different types of communication that can go on the network, whether that's voice, voice over IP, telephone calls, or video, or telepresence, or chat, or email. Those are all forms of communication. But that's actually, we don't make the same distinction when we're looking at troubleshooting from a network perspective, and there's a good reason. That's because the real difference on the network side is which traffic is truly real-time and which is not. So there's a large subset, probably the most significant subset of unified communications, voice and video, that are real-time communications. The packets have to get there on time. If a packet or a number of packets are dropped along the way, they can't fit back into the stream, and they're just lost from the communication. So you have dropouts or a breakup of the call, those types of things. So that information has to be transmitted now. Email, chat, or any other data on your network for that matter really can be transmitted at any time. I mean, the user experience might suffer terribly if they're waiting, minutes for a page to download because not all of the packets have arrived there, but eventually, assuming they all get there, you could put it back together. So there's a huge distinction there. And where that comes from is really, what were the initial communication? Was it analog or was it digital? Email, always digital, right? It's just bits representing letters, which represent words, which represent paragraphs, and again, you could put it all back in time. But something that was analog, voice or video, the original shooting of the video, anything that had that analog component to it that was then, went from analog to digital, you can't wait too long for packets because it's streaming. You're watching it in real time, or you're listening to it in real time. You can't add additional delay and still make the communication work. And it's especially true in something that is two-way, like telepresence or or audio. Maybe if you're streaming a video, a larger buffer, etc., you can handle some of that. But there are definitely elements to this that are crucial from a real-time perspective. And that's really the focus of all of the metrics that we have on the network. So what are the key metrics? Well, it's really packet loss, latency, and jitter. You can look anywhere on the network, start reading about voice over IP and quality metrics, and these are the three network elements that are going to form the basis of the quality metrics. These characteristics or problems, however you want to classify these, exist on networks today. They always exist on networks. There's always latency. There's always some element of packet loss, and there's even some element of jitter. But the thing is, again, on a traditional network where we're only moving TCP/IP data, and it truly is only data, most of this fades into the background. Certainly latency and packet loss may, again, contribute to the user experience some, but you can continue to retry and retransmit until you get things right. Not true with the real-time elements of unified communication. And jitter is something we rarely talk about from a network perspective at all when it comes to TCP/IP data. Jitter is the separation between the packets as they're delivered. And again, in a real-time protocol, because it started from an analog signal and was a nice smooth signal, right, with a whole bunch of frequency content in it, but it was something smooth. It was regular. So the same thing is expected once it's digitized. All of the receivers that are taking the packets that originally VoIP want a similar spacing, actually want the exact same spacing between all of the packets so that it can put it back together in that same smooth format. And jitter is where the separation between the packets isn't quite the same anymore. Some packets are a little closer together, some packets are a little further apart in time, and then our receivers of this voice communication need to work harder to put all that back into the right order and with the right separation. So jitter is a problem that's mostly unique to unified communications, to the real-time aspect. Again, packet loss is, as it says, and can be exhibited on any network, and latency is just the delay it takes to get there. Again, maybe not an issue if it's more of a one-way communication. If traffic is going from one thing to another, and it's not bi-directional where somebody's waiting to hear something and then answer in real time. When that happens, latency becomes much more of a problem because I say something, I'm waiting, expecting for you to say something, and if I wait maybe a third of a second, and that's kind of where the processing in my brain is going. I don't hear you speaking. I may start to speak again, and then you start to speak. And that's, of course, some of the problems we have with digitized voice communications today, and that's where latency comes in. So enough of all that. What happens with that is, those three areas form the basis of mean opinion score and R factor, which are two of the critical metrics that are used in monitoring the real-time aspects of unified communication today. So just leave it at that. Again, things that we covered last time. So what are some of the best practices? So as I said earlier, first, we want to approach the best practices from an implementation standpoint, from getting unified communications set up. What should we consider when we're setting up unified communications? And I've broken this down into three areas. The first is just enterprise, just general. And what I mean by enterprise is a reasonably large organization, hundreds of people at a single location or up from there, something fairly large where there's a reasonable network infrastructure in place, where there's a high-speed network connection or multiple high-speed network connections in place. That's an enterprise. We're also going to cover small offices and cloud here in a second in terms of implementation, because there are some different things to worry about in each of those different situations. So for enterprise, certainly, conducting a survey before implementing the unified communications is, you'll see this over and over again on, out there for any reading you do on unified communications as being, the first real critical step. And a site survey, can be done somewhat manually. There is software out there that does site survey, but basically what the site survey is telling you is it's making sure that the current network you have is really capable and up to the challenge of unified communications. So we need to remember, 10 years ago, unified communications mainly meant voice. And voice itself, though it has the real-time component to it, is very sensitive to those parameters that we talked about. It doesn't send a lot of data. It's mostly small packets, and the data rates are very low per call. So it didn't put a tremendous strain on your network overall, but the traffic that was or is voice, it needed to be prioritized. But now, fast forwarding 10 years to today, a lot of our unified communications traffic is video, which has a very large bandwidth footprint, especially if multiple people are doing video at the same time. Everyone on the same conference, the same telepresence or the same teleconference call, we're all on GoToMeeting, and we all have our cameras on. Again, all of that is just more and more real-time data that needs to ride on top of our traditional data. And we need to really make sure that, number one, our networks are up for that, and make sure that, that we have the right equipment in place to prioritize traffic in the appropriate way, so that we can make sure that we're maintaining the quality of all of those communications. Modeling is something you can do with software. You definitely want to model it before you deploy it. Third, and probably most important, is using quality of service at all the network hops. So what the quality of service is basically something built into packet communication, where you can provide, where switches and routers, if appropriately supported, can give priority to certain packets if their quality of service setting is higher than other packets. So we might give our voice traffic the highest quality of service setting, maybe video one step below that, because voice is even more sensitive to all of these real-time parameters, and then we give all of our other traffic the lowest setting in terms of quality of service. So now whenever any packet hits a switch or a router, if it has the highest priority, the switch or router will make every effort to give it the highest priority in terms of routing that packet ahead of other traffic that might be in the queue. So quality of service is very critical. It helps us do a number of things. It helps us reduce the latency. In some ways, it helps us reduce the packet loss, and when we reduce the latency, we tend to improve the jitter a whole lot. So using quality of service is probably one of the, I think it is the most important thing you can do for network traffic, for voice over IP and unified communications traffic. And lastly, and there's a lot of debate over this, is whether you try to organize and isolate your unified communications traffic in some sort of way. One of the ways that's often recommended out there is using VLANs. Again, there's a lot of debate here and a bit of a holy war going on about VLANs. There's people with very strong opinions about this. I'll offer you mine as well, which is that VLANs really were designed for securing network traffic. They really don't provide, a real level of segmentation. There is some aspect of that. I won't deny that. Certainly when you're trying to view data later, it's pretty easy to isolate data from a viewing perspective by VLANs because it's been tagged a certain way. But just because you've put some traffic on one VLAN and some on another, it is still all sharing the same network, regardless of how you try to segment your unified communications traffic from your traditional, data traffic. If it's all on the same network, all going through the same switches and routers, it is sharing the network. It doesn't really matter what that underlying method of segmentation or separation is. If you truly want to try and isolate or segment your unified communications traffic, it's better to try and do it with either, number one, just on its own subnet. That's another way of being able to keep track of the data without having to involve the complexity of VLANs. And Or if you really want to isolate that traffic, then setting up separate network components. If it's a large enough network and you have the capability to do that, you could route that traffic separately well. But eventually, it's all going to wind up in the same place. It's all going to wind up going through the same core router or switch. So eventually, it is all going to end up together. But it all depends on what your goal here, right? Is your goal visibility into the traffic? Then segmenting it by subnet is probably quite adequate. If your goal is really trying to verify the quality of that, and you want to give it every best chance possible, running it through its own network gear, to the degree that you're able to do that, will give it that little bit more edge in terms of quality, but it's still not going to make it's not going to make all of the difference, because still at some point that traffic is all going to get rolled up together in a core switch. It's all going to go out over the internet together by itself, and at that point you've really lost control of the quality elements of that data transmission or that packet transmission until it comes back into your network. But my opinion on VLANs is it is truly not necessary. In many ways, it's overkill. And in a large network, if you already have VLAN capabilities, then that is another way to separate that data for visualization if you choose to do that. But as your networks and your office sizes get a little smaller and a little smaller, you may not even have the appropriate equipment that is VLAN capable. And if not, I really wouldn't sweat it, because I don't think that's always the best approach. Second area of implementation are small and remote offices. So in contrast to the large enterprise, maybe offices that are 50 or less. And in a lot of cases, offices that are maybe even smaller than that, like 10, 15, 20 people. Some of the things you might want to consider there are a little different than in the large enterprise. So first, you really want to make sure that the switch that you're using for your network and that connects you back out to your WAN is able to support voice. In a lot of really small offices, 10 people or less, we often find that people have gone very much on the cheap and treat that small office more like it's a home. And they buy, commercial home-grade equipment from Best Buy or on Amazon and use that as their switch. In a lot of cases, it doesn't even support voice, which basically, it means that your latency is going to be much higher through these devices, right? They really weren't designed for that. They don't really take the latency requirements of things like voice and video into account. And they add way too much delay to your transmissions. And that will definitely cause you a whole lot of problems. I don't know if you recall from the last time we talked about metrics, we get into more detail on these, but when it comes to latency, you have about 150 millisecond budget. That's it. Once the latency gets above about 150 milliseconds, it starts to create user experience problems. So looking at your switch is the most important thing there. Again, you can do some separation of voice and video if you want to, but in offices of that size, 50 people or less, or 10 or 20 people, even trying to do that network separation, whether it was by VLAN or subnet or whatever, it really doesn't have much of an impact in terms of the small office. Definitely need quality of service, though. And another thing to consider in that small office is having dual internet connections. You may not have subscribed to, a T1 or T3 or some large and reliable internet connection at your small offices. You might just be using an internet service provider. And if so, it's very much recommended to contract with two service providers and use them in parallel. You can either, truly put them in parallel, or you can ask your unified communications to go out on one and your data, typical TCP IP transmissions on the other. You can segregate it that way through your switch, and then you have both, and you're giving yourself that much more of an edge again for your unified communications. And the nice thing about that is if one of them goes down, well, then you can at least have the other as a backup to run all of your data until the first one comes back up. And just last, for those of you who have been to a lot of Savvius webinars and know me, you know my passion for wireless. I love wireless. That's really an area where I've dug in deeply in terms of the technology. But I would stay away from voice over Wi-Fi in these small and remote offices unless you're really equipped to do some troubleshooting there, because wireless situations are far more detrimental to voice and video quality than anything you're going to find on the wire. Lastly, in terms of cloud hosted, it's kind of a new trend where now companies, especially small offices, aren't even wanting to implement any of the unified communications aspects themselves. They were going all to unified communications as a service type of thing. The biggest thing there is asking questions. It's still understanding all of the things we've talked about in these webinars, things like the jitter, the packet loss, the latency, and asking questions about that, right? Like, what is your latency for as a software as a service provider? Are you going to give me an SLA on latency? Can I measure the latency? Because I can measure it from my perspective. If I measure the latency from my perspective, are you going to guarantee me the SLA there? Where does that come from? Knowing more and challenging the provider, the UC software as a service provider more and more on these issues of metrics, and showing that you know how to manage and monitor and ensure the quality of unified communications to them will put them much more on their game for giving you the best service possible. Keep in mind, cheaper doesn't mean better. If you ask the right questions, this won't be so much of a problem. But if you're just shopping, it's really a buyer beware kind of market right now in that area. Of course, know your VoIP quality metrics, which is part of the reason why we're talking about this. And then pay attention to upload speeds. And this probably also pertains to the small offices as well. Our internet service providers are really good with the download speeds, not very generous with the upload speeds. For just voice, maybe not an issue. If you're going to do a lot of telepresence as part of your unified communications where you're going to have video, pay attention to those upload speeds as well. The dual internet connections play well here as well. And of course, you do want quality of service on your own firewalls and switches on your end, even if you're going with unified communications as a service, because again, you want to ensure that the best quality possible, at least from your handsets, at least out till it gets out to the service provider. So in terms of troubleshooting, what are some of the best practices? We want to deploy analysis tools to achieve maximum visibility. I'm going to have a little slide on this. Actually, each one of these we're going to get into in a little more detail by looking at OmniPeak, and because we're running a little short on time, it's only a half-hour webinar, I'm going to skip ahead and we'll start switching back and forth between these slides and OmniPeak here in a second to see these things. So in terms of in terms of monitoring for visibility, well, if you're an enterprise, for sure, you want to be able to monitor, at your data center, at your corporate office, near your core router and switch where your traffic's going out to the internet. And there are appliances to do that. WhatCircle is just an example of one of ours, but you definitely want to monitor there. But if you also have remote offices in the mix, you want to monitor at the remote office for several reasons. Number one, you want visibility at that remote office. Depending on the way your unified communications are going to get routed and the service behind each of the individual unified communications, that data may not even be getting routed back to your data center. It may be getting routed out to the internet and out to its final destination. So you'd have no visibility into that traffic without an appliance out at the small and remote office. In addition, when we have one in each place like that, now we're able to actually measure very, very precisely the latency in between those 2 points. I will always know packet by packet the latency between my corporate office and my small office, and that's again a very important metric as we've discussed. The beauty here with the small and remote offices is we've recently introduced a product called Insight, and just yesterday introduced an update to Insight. Insight is from a network monitoring perspective, a very inexpensive appliance that is priced such that it could be at every remote office or every retail office if you're retail, or every store if you're a retailer, or every fast food outlet if you're Burger King or you're McDonald's. It's priced appropriately so that you could put one in every place so you can have visibility at each one of those locations. So in terms of the troubleshooting, we talked about deploying the analysis to maximum visibility. That was that last slide. One of the things we want to also be able to do is baseline with and without UC. Baselining would basically mean, in terms of something like OmniPeak, having views of your network and your applications. Who are, what is the utilization in megabits per second? What does the activity look like? Who are the top talkers? Who are the top protocols, etc.? Understanding that and saving records of this. And you can certainly do that from within our software, from within other software as well. Run a capture over a length of time, store that data, know what it looks like. Do it at different times of day, do it at different weeks so that you can compare that data, again, before you even do unified communications, then deploy your unified communications, and then look again. The third, in terms of best practices for troubleshooting, is correlating the UC metrics with bandwidth utilization. And that is, from my perspective, one of the key things that you need to be able to do. And what that speaks to is it speaks to, let me go to this one instead. Not that one. I lost my sample. Hold on. What it speaks to is it speaks to the need to be able to see everything at one spot. One of the issues today is a lot of times for unified communications, most users rely on things like their call managers to tell them the information about their unified communications. And I'm not saying they don't do it truthfully. Of course they do. But the call manager is most often not taking anything about the rest of the network into account. It's taking your unified communications into account. What you need to be able to see are things like we're looking at in the bottom graph, where we're overlaying our network utilization over our call utilization. Basically what's going on there is we're overlaying all of our data on top of our real-time protocol, which is any of the data, voice or video, that has a real-time component to it, right? That has to get there, all of these things we've been talking about. And, it's areas like here where we see where it says max, those are the areas we want to look at, right? Hey, in that point in time, I saw a spike in my network traffic. Did that affect, as I just kind of scroll up here, did that affect my call volume? What was the call volume? No, we had an even call volume through. Did it affect my mean opinion score in that time? Nope, we had a mean opinion score of 4.17, which is a great mean opinion score. It was consistent the whole way through. In this particular case, we look and we have 100% good calls, and that makes sense because even though we had spikes in our network traffic, those spikes were not enough to affect the underlying delivery of our real-time protocol. Being able to see this kind of information all together is truly key. You want to be able to measure and analyze the call quality metrics. Of course, we need to be able to do that. And what we need is a solution that's able to do that pretty much on the fly, which is exactly what we're able to do with, let me switch to this one instead, with OmniPeak and our appliances. So in our calls in media view, specifically in our media view, we are able to isolate from a packet perspective each and every call on your network and the specific direction of the call, right? So here, that was one direction of the call that was out from 5.1.157 out to 1.9, and then here it is back in the other direction, right? And that can be, and often is, very important because the mean opinion score and things like jitter and packet loss can vary tremendously depending on the direction of the call. And for every one of those calls, I can look down in this area and all of my metrics are here for me to see. I had 20 milliseconds or 28 milliseconds of jitter, 0 packet loss, 69 milliseconds of one-way delay. That would imply a pretty good call, and sure enough, I looked down at my mean opinion scores, all above 4, I know I had a good call. So in that particular case, I know. If I'm trying to troubleshoot, I can go from a different perspective rather than looking at it by call number. I can come in and turn on mean opinion score, which I know can't find. Is it already on? There we go. Mean opinion score. The conversational quality. I see what my scores are, and I can ask my software to rate them, to just move my calls around and now list them by mean opinion score. Scroll down, I can see where my twos are, and then from there quickly zoom in on that call instead and see what its hops were, etc. So being able to see these metrics is critical. Also being able to automate that UC analysis, right? So one of the other things that we've talked about is things like, again, not marked for QoS, or excessive jitter, or excessive packet loss. Those are all things we want to know. We don't want to have to analyze those for ourselves. And again, the great thing is we can have software that does that automatically for us. So here in this event summary, in the background, we're also analyzing for all of these different possible problems on the network. Things like late packet arrival, packets that are out of sequence, not marked for QoS, low MOS, excessive packet loss, excessive jitter, all the things that we want to know found out for us automatically. And if we find one, like one of these where, let's go look where excessive jitter is detected, well, I can just click on it, and it will then show me which calls were experiencing the excessive jitter. Very, very straightforward. Basically done for you totally automatically. You want to know if there's bad jitter, you know there is, and now you even know where it is, allowing you to very quickly drill in and see who was affected, to continue to monitor that user to see if they continue to be affected, and then drill in a little bit further and see, well, where is that traffic being routed? Is there a problem? Things like the not marked for QoS is a key one, right? In this case, we have 11 different counts of not being marked for QoS. We would want to route, follow our tracing for these calls and figure out, which router or switch is in common, and, is it that switch or router that is not marking the packets for quality of service, and if not, why not, and get that rectified. Verifying the quality of service at all network hops and being able to verify. Another key area where, as I mentioned earlier, if you have multiple measurement points, you can now measure that latency accurately between each of those points. This diagram represents somewhere where we actually have 3 different measurement points, and we can see the latency between those. So we see here we only had 1 hop between, so we know we've caught the traffic as it goes from 203 to 202, and we know exactly what our latencies are, right? A millisecond, which is really good, right? Here we had 2 hops, so we know we might have missed a hop. So, this latency actually represents 2 hops in the network, so there's 1 hop that's kind of hidden, but the latencies are still really low, so maybe not a worry. But again, every additional measurement point, maybe, again, using the appliance at the data center and the smaller appliance out at the remote office, gives you more and more detailed information to be able to quickly isolate a problem. And the last 2 things, being able to look at maybe network segmentation or upload speeds. Both of those are also, very, very easy to do. We can go back into our packet examples, and for looking at things like, overall upload speed, we can come back to our different dashboards like Compass, and in Compass we are able to distinguish between directions between transmit and receive, so you can quickly see your transmit and receive traffic very, very, very quickly. And for things like network segmentation, it's very easy to go to something like our peer map, where you can see from a network perspective how everything is interconnected with each other. So if we choose a certain number of VoIP calls, we'd be able to see exactly, what our connectivity is between the caller and the callee for each of those calls. So I know that was kind of a quick tour through in terms of the best practices, but hopefully the point I was able to make there is that OmniPeak and our associated appliances, if you're using an appliance, is doing a tremendous amount of voice over IP analysis in the background, and basically just metric in general, unified communication metrics in the background. All of the metrics that are key to your unified communications are being monitored, calculated, measured, monitored, and we're rolling things up a layer, looking at things from the perspective of calls, and correlating all of this data up into calls, and then letting you know for any given call when are we seeing any of these problems. So it allows you to very, very quickly troubleshoot all of the common and even not so common issues with unified communications on your network. We also have some dashboards for our Insight unit that will allow you to capture data over time for voice over IP. So in summary, between the last webinar and this one, hopefully I've made the point that unified communications data on the network is fundamentally different from your traditional TCP/IP data. The real-time aspect of it is key and cannot be ignored. It is still one of the main concerns for network and IT engineers. You know, even after all this time, after 10, 15 years of unified communications and VoIP being deployed out there, it's still the most common problem for IT engineers. The UC data is far more vulnerable to network issues like jitter, latency, and packet loss, and that's especially true on wireless. Troubleshooting your unified communications really requires that you look at the network as a whole. You need to see your real-time traffic and your other traffic all in one view on the network so that you can see when one is influencing the other. It does require careful planning, and of course you want to put solutions in place that are able to do this UC analysis for you automatically, to be able to find the jitter problems, the quality of service problems for you automatically on the network.